Hello there, everyone. Today I'll be using complex numbers and de Moivre's theorem to derive some trigonometric identities. So yeah,
Fun, and I'm just gonna, because I don't know this, so I'm just gonna sit here and listen.
just
So
gonna
tell me.
just gonna tag along for the ride.
Tag along.
Okay.
Like a leech.
So you're aware of modulus, are you?
I
Modulus.
am, yes.
You know modulus with complex numbers.
Sure.
Okay, I'll explain it. So the complex number formula, oh, that was horrible,
Mm-hmm.
is a plus ib,
Yep.
or a plus bi. The
Yep.
same thing.
Yep.
And the modulus is a squared plus b squared rooted. Do you understand that?
Yep. Yeah, that makes sense.
So if z equals a plus ib, then modulus z equals that.
Yep. That makes
The
sense.
parts are good? Okay.
Yep.
And the argument is, well, a plus bi, if we plot that on the axes, we have real and imaginary. You can see that, right?
Yep.
If we draw a line and a is here, no, wrong way around. Because we've got a as the real part, a goes up here,
Mm-hmm.
and b is the imaginary part, so that goes there. And we have this angle, theta, and you can explain to me how we get theta. Can you?
Trigonometry.
Yep. So obviously, you know what's the tan equation.
Oh right, tan theta will give you a over b.
Yep, because a is here and b is here. So what that means is theta is something, and that theta is the argument. Okay, so basically the angle theta for a plus bi, that's what the argument is. And the modulus is a squared plus b squared rooted, like Pythagoras' theorem. So Pythagoras is one way and trigonometry is the other way. And here's where it gets funky, where we have the cool notation, which I will not show you. I'll show you later.
Oh, I want to see this notation.
But I'll show you some different notation.
Sure, sure.
Here, we have r cis theta.
I've seen this before, but I've never known what it meant.
Well, it's actually an acronym in a way for r cos theta plus I sine theta.
I see.
Obviously, the R corresponds to this, C corresponds to that,
Yeah.
and you get the idea.
Hmm. But what's R?
Oh, that's what you're multiplying by the whole thing. So
But what is it in this case?
it's just R.
It's just R. Okay. Okay.
It's got
Okay.
no value to it, but it's just a thing you're putting in front of it.
Yeah. Yeah. Sure. Sure. Sure.
Okay. So that's de Moivre's theorem, the thing I just showed you. No, actually, that's not. This is de Moivre's theorem. So we have
Right.
R. Bring that back.
Sure. 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 Sure.
And if we put this to the power of n, then de Moivre's theorem states that r to the n. Okay, you know, I'm just gonna call it cis theta because that's quicker.
Yep. No, I get it.
Yeah. So these are the same.
Whoa, that's cool.
So de Moivre's theorem says you can put the n outside the brackets into the r. So actually, the whole thing is being put to the power of n, but you can just put
Right.
the n
Okay.
at the front. So that should make things a bit easier. And then this n value, we're going to set that to 3, and we can use that to prove some trigonometric identities. You know the cos 2a. Do you know that?
Yep.
What is that? I can't remember.
Oh.
Do you remember off the top of your
I've
head?
got a little formula booklet here. I'm just going to sneak a look at it. Because, that's what formula books are for, right?
Yep.
What do you want it in terms of?
Yeah, cos 2, in terms of theta and alpha. Oh no, you just do it in theta, can't you?
Yeah, but with causes or sines or...
Oh, both of them.
Okay, well, it's cos squared theta minus sine squared theta.
Oh yeah, cos 2 theta equals cos squared theta minus sine squared theta. Now that's a cool equation. But we also have to remember that cos squared theta plus sine squared theta equals 1. So don't forget the minus sign there.
Mm.
I'm now going to show you what cos 3a is. What cos 3 theta is. Do you know what that is?
Well, cos 3, I don't know.
Okay, yeah, this is the fun bit. We're going to use complex numbers and everything I've just showed you to prove that.
Ooh.
So,
Putting them all together now. Okay, go on, show me.
this is where the fun begins. We're going to do a third theta, cos a third theta, plus I sine a third theta, and we're going to let n equals 3. So the whole thing's being put to the power of 3.
Okay.
Okay, it's going to take a while. If we expand the left-hand side, you just have to accept what I've done. And okay. So this is like we're just expanding out the brackets.
Yep. I'm sure it works out.
Oh, I'm just going to say cis theta equals this, what we've just done. And theta is the third theta.
Okay, sure. Yeah.
I'm just thinking. Okay.
Oh, it's gone. Oh, that's some funky colours.
There. So you just have to accept that this equals this.
Yeah, I believe it.
If you believe hard enough, it is true.
It'll be true. There you go.
And then we're going to say theta is the same as 3a. So now a third theta is going to be, so theta is 3a. So now we're going to do some manipulation. And by using the power of imagination, we're going to assume that this equals, well, not assume, I could show you the full breakdown, but that'll just take a while. Cos 3 alpha equals cos cubed alpha minus 3 sine squared alpha cos alpha. Let's just accept that's a thing.
Wait, where does that come from? Oh, that's just true. Okay, fine. Yeah.
No, what was I trying to... Okay, I figured it out. So at the beginning we said cis theta equals all this. And because the sine theta, that's imaginary, we're just going to ignore that. So we're just taking the cos part of it. So cos theta equals this whole thing. And if cos theta equals long thing, but we're taking out all the I parts, because when you're doing equations, you keep the real parts and the imaginary parts together. So if we're doing real, we're doing cos theta equals just this bit.
Yeah, yeah.
And now we're letting theta equal 3a. So now this goes to this, if that makes sense.
Yep. That does, yeah.
We'll come back to the I bit later, so just pretend you remember that. And now since sine squared alpha plus cos squared alpha equals 1, we can show that cos 3 alpha is the same as taking this. We can show that cos 3 alpha equals 4. Oh, where's it gone? There it is. Rubbed out the whole thing. Equals 4 cos cubed alpha minus 3 cos alpha. And then that's your answer. So by using the cis theta function, we've just used the cube. We've just split it up into real and imaginary, and we've used the real parts to give us an identity for cos 3 alpha. Which is pretty bad proof because I got confused halfway through. But that's the answer.
No, it's good. Oh, that's cool.
Okay, I think there's one more, which I can
Cool
show.
how you can like prove something is true for real numbers by using complex numbers.
Yeah.
Nice little. That's a crossover right there.
Oh, I should have said something at the beginning. When we had the whole thing being cubed, that 3 goes into the theta to make it 1 over 3 theta, I believe.
Oh right, yeah. I think this.
Actually, let's just ignore that. This one's, sine theta, sine 2 theta, but do you know sine half theta?
Sine 2 theta.
Have you ever seen that?
No. Yeah. What about it though?
Oh, have you seen what it equals?
Oh, isn't it 2 sine half? Oh no, I haven't seen it like this then. Oh no, I haven't seen that. Oh wow, okay. No, that's cool.
And now I'm going to prove that.
Huh.
Somehow. Because before we did proof using the real part, this time I'm going to prove using the imaginary part.
Oh, I see. So this is using that imaginary chunk that we just.
No, similar. But this time we're going to split an equation into real and imaginary. We're going to use the imaginary part.
Oh yeah.
We're just going to forget about the imaginary section from before.
Yeah, sounds good.
Okay, going back to Moivre's theorem, we're going to do cis theta to the power of a half. If that makes sense.
Mm-hmm.
And we know that equals cos half theta plus I sine theta, because that half at the beginning is going into the theta. If that makes sense. Now, if we square both sides of this equation, we get cis. Remember, something to the power of a half is the same as rooting it. So cis theta equals cos squared half theta minus sine squared half theta plus I 2 sine half theta cos half theta. I'm going to put that in yellow brackets.
Yep.
So the real is the blue
imaginary part.
And the imaginary part is the red.
Yep.
And because it's I sine theta on the left, we're going to split up. So I sine theta equals what's on the right. So I sine theta equals this. And obviously you can cancel out the two i's. So sine theta equals 2 sine half theta cos half theta. And if we break this down even further, we get suspense. What have I done? Okay, so we're going to say for this, cos squared half theta plus sine squared half theta equals 1. Because that's our normal equation. We're just saying that theta is a half.
Yeah.
And by using that and the power of imagination, if we substitute that into that should do some breaking down, and somehow.
Oh, I see, because you'll end up with a square root in there somewhere.
Yeah.
The first one.
Then the equation does some cool stuff, and we get our answer. Yeah, that was it.
What was it equal to again? Sine a half theta is.
And then our final answer is sine half theta equals 1 minus cos theta over 2. The whole thing is rooted.
Oh, that's a fun result. Very interesting. Cool that you can do that with complex numbers.
Yeah, you can split up anything into real and complex and get a cool answer. So yeah, that's it. I hope you enjoyed this video of me explaining some cool math stuff. And obviously my explanation's one explanation. If you want another explanation, you can go online and find someone else talk about de Moivre theorem, because obviously it's quite a big part of complex numbers. So yeah, I hope you enjoyed.
Give us the views.
Give us
we
the
want
views.
The views.
And then give some other people some views. Make everyone happy.
I guess that makes sense.
Okay, so thank you for watching, and remember,
Thank you.
math is the way.
Math is the way.